Errors in measurements. Now, in this world, nobody is perfect, and we all make mistakes, and we all learn from our mistakes. So even in physics also, while making any kind of measurements, some error will always be there. Okay, so if you're measuring any physical quantities, okay, you will not get a precise measurement, because error will always be there. And there are different types of errors. The first types of error, they are known as systematic errors. This is the first type, systematic errors. Now, systematic errors are those errors that tend to be of the same sign, okay, either positive or negative, and these errors can be eliminated by knowing the sources of the systematic errors. Now, one of the source of systematic errors is instrumental errors. This is one source of systematic errors. Instrumental errors. Now, instrumental errors are errors which are there in any instrument, either due to the manufacturing or defection, or due to improper calibration. For example, if I take my watch here, now in this watch I have calibrated this watch to be much more faster. So if I measure time by using this watch, okay, or if I tell you the time using my watch, then it will be faster than your watch. So here there's an error in calibration. So this is known as instrumental errors, okay, errors in instruments. And the second type of source of systematic errors is imperfection in the procedure or the methods that we are doing in performing an experiment. So imperfection in the experimental methods or procedures. Okay, so while doing any experiment or while measuring any physical quantities, there are a set of procedures in which you'll have to follow to minimize the errors. So these procedures you'll be doing in your practical classes, okay, and mostly in practical class you'll be measuring the thickness of a sheet by using a screw gauge, the diameter of a cylindrical body by using a vernier caliper, and there are methods and procedures in which you'll have to follow. And if you don't follow these procedures, there'll be errors in your measurements. Okay, so the second source of error for systematic errors is imperfection in the experimental methods. Okay, so you have to follow the procedures given to you while doing your practicals. And the third source is personal errors. So this personal errors, okay, it's an error in which arise due to your own lack of proper setting of the apparatus, or due to your carelessness. Sometimes you may not take the reading properly, sometimes you may not follow the procedure. So personal error is error from your part, okay, you're not doing it correctly. So these are known as personal errors. So these are the source of systematic errors. Okay, the first is instrumental errors, the second is imperfection in experimental methods, and The third is personal errors. So these are all known errors, and they can be minimized by taking precautions. Then the next type of error is known as random errors. Now these random errors, they are unknown errors. We do not know the source of the errors. Even if we have calibrated the instrument properly, if we have followed the procedure very carefully, and if we have measured the quantities from outside very carefully, even if we have minimized all these systematic errors, some error will always be there, and these types of errors are known as random errors or chance errors. You do not know the source of these errors. Okay, they may be of external factors which are unknown. So such type of errors are known as random errors. There's another type of error which occurs in both the systematic and random errors, and these errors, they are known as least count error. Now what is this meaning of the least count? Okay, least count is the smallest value that can be measured by the measuring instrument. For example, your regular scale. If you look at the centimeter scale, it has a least count of 1 millimeter. It means that it cannot measure anything which is less than 1 millimeter. And your vernier caliper, okay, has a least count of 0.1 millimeter. The vernier caliper, this is for your regular scale or centimeter scale or meter scale. Now right here, meter scale. Your regular meter scale has a least count of 1 millimeter, and the vernier caliper has a least count of 0.1 millimeter. This is for vernier caliper. And the least count of your screw gauge is 0.01 millimeter. So this is for the screw gauge. Okay, so out of these instruments, which has more accuracy? It is the screw gauge. This one has more accuracy because it has a least count of 0.01 millimeter. It can measure, okay, the thickness of a sheet, or the thickness of the wires, or the diameter of the wire. Here you can measure the diameter of a spherical body or a cylindrical body. And meter scale, okay, you can just measure the distance or the length of any object. Okay, so out of these, this has much more error because it can only measure up to 1 millimeter, and the screw gauge has the least error because it can measure till 0.01 millimeter. Okay, so that is the least count error. Now, how do we calculate the errors in measurement? Now, there are three ways in which we can express the errors in measurement. One is absolute error, the other one is relative error, and another way is percentage error. So these are the three ways in which we can express the errors in measurement. Now, how will we calculate the errors in measurement? Now, to find out the errors in measurement, we'll have to know the exact value of the measurement that we are making. Now, the exact value may be given to you, or you may have to find out the values of the measurements, the exact value of the measurement that you are making. And to find out or to calculate the exact value of the measurement, what you'll have to do is you'll have to make several measurements, okay, not just one. Suppose you're measuring the diameter of a wire. Here you'll have to take several measurements, that is from different points. So let A1 be the first measurement that you took. Then again you take another measurement. It may be different. You'll get A2, then again you take another measurement, you'll get A3, then you'll take another measurement, you'll get A4, okay, and you do this till any number of times, n number of times. Okay, so you make n number of observations. Okay, maybe 5, 6, 7, 10, okay, whatever number of measurements. Now after you've taken all these measurements, if A1, A2, A3, A4, okay, A5, A6 till AN, to know the exact value, you have to divide this one by the number of measurements, which is n. So this is known as the mean value, or the true value, or the exact value. A mean. So this is known as the exact value, or the true value of the measurement. If, for example, you take 5, if you take 5 observations, then the true value can be calculated as A mean. So if you take 5 values, then you have A1 plus A2 plus A3 plus A4 plus 5, A5, which is 5 observations, then divided by 5. Okay, so in doing practical classes, while making any measurement, especially while finding the diameter of the wire, you'll have to make at least 5 measurements or 5 observations. Then you'll have to divide that one. You have to take the mean of the measurements, that is, sum all the measurements and you divide it by the number of observation, which is 5 in this case. So that's how you find the true value. So this one will give you the exact value, or the true value of the measurement. So all these you'll have to apply during your practical classes, okay, while finding the diameter of the wire or finding the diameter of a cylindrical body. So keep this formula in mind. The mean, or the true value, is given by taking the sum of all the measurements, then dividing the sum by the number of observation. So we have known how to calculate the exact value, or the true value of a measurement. Now we'll have to calculate or know how to find the absolute error in the measurement. Now the absolute error is the magnitude of the difference between the individual measurement and the true value of the physical quantity which you are measuring. So if you have to find the absolute error, what you'll have to do is, first you'll have to take the difference of the individual measurements, okay, and the true value. If, for example, the delta A1, this will give you the difference between the measurement A1 and the true value, which is the mean value of the measurements. Then again, for A2 also, you'll have the difference A2 minus A mean. Then the delta A3 also, this is the difference of the individual measurement A3 and the true value A mean. Okay, so this till n observations. This will follow till n observations. Now this value, it can be negative. The difference can be negative or it can be positive. It will be negative if this true value is larger than the measured value. And here also, if this is smaller than the measured value, then this will be positive. If, for example, you will get, suppose if you get here 1 and the true value is 2, so what you get is minus 1. Okay, so this is a negative value. Suppose you get here 2, then the exact value is 2, you will get 0. Then for example, you get here 3 and the exact value is 2, so what you get is 1. Okay, so it can be negative, it can also be 0, it can also be positive, but the absolute error is always positive. Okay, you just take the magnitude. So what you have to do is, we'll take the modulus of this one. So modulus of this, modulus of the difference, modulus of the difference. So modulus of the difference. Once you take the modulus of the difference, then this minus sign here will become positive. Okay, so this will be 0, this will always be positive. So absolute error is always positive. Okay, so it doesn't matter if the difference is comes out to be negative, the absolute error will always be positive. Okay, so that is the absolute error. And there's another way. Here you have n number of observations, so you'll have to take the mean absolute error also. Okay, suppose you have n observations. So this will be the absolute error of the individual measurements. So the mean absolute error, what you'll have to do is you'll have to add all these individual absolute error and you divide it by the number of observations. So the mean absolute error delta A mean, this will be the sum of all the individual absolute error, delta A1 plus modulus of delta A2, then plus modulus of delta AN. Then you'll have to divide this by the number of observations. So this will give you the mean absolute error. So this is one way in which you can express the error in measurement in terms of the absolute error. Now another way of expressing errors in measurement will be in terms of the relative error. Now this one is very simple. Once you have found out the mean absolute error, that is delta A mean, this is the mean absolute error which I've shown you in the earlier slide. So the relative error, your relative error, can be found out by simply by dividing this mean absolute error by the true value. So once you divide this one in terms of you divide the mean absolute error by the true value, then this will give you the relative error. Then we go to the next one. We can also express error in measurement in terms of percentage error. And in terms of percentage error, what you do here is just multiply this with 100. So we have the mean absolute error divided by the true value into 100. So this will give you the percentage error. There are three ways in which you can express, remember, there are three ways which you can express the errors in measurement. One is absolute error, the other one is relative error, and the other one is percentage error. In all these calculations, you'll first have to find the true value, which is the mean value of all the observation that you have taken, or in some case the true value will be given. In some problems the true value will be given. So you all need to find is the absolute error. After you found out the absolute error, you can find the relative error just by dividing it with the absolute error with the true value, and you can also find the percentage error just by multiplying this relative error with 100. Okay, so this is how you will calculate errors in measurements. And remember all these formula, you'll be doing all these in your practical classes. For example, let's take this problem here. So we measure the period of oscillation of a simple pendulum. In successive measurements, the readings turn out to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds, and 2.80 seconds. Calculate the absolute errors, relative error, or percentage error. So here we have a pendulum. So this will be the solution of the problem. So what is a pendulum? A pendulum is any object which oscillate about a point. For example, if we have this any bob here, then it oscillates about this point, and this is the wire or a thread, and this bob, it can oscillate about this point. Okay, so it goes in this direction. So from this point it will go here, then it will come back to this point, then it will go here. Okay, so this is a pendulum. It's oscillating about this point. Now, what is the period of oscillation? Period of oscillation is the time in which it takes to complete one vibration. It means that if we start from here, suppose if we start from here, we go to this extreme position, then we come back to this extreme position, then the time it takes to go from here to here and back to the same position, that is known as the period of oscillation. And it's given that the period of oscillations is taking in the successive measurements, and those measurements turn out to be 2.63. This is the first measurement, so I'll take this as the first reading. Then the second measurement will be 2.56 second. Then the third will be 2.42 seconds. The fourth is 2.71 second, and the fifth one is 2.80 seconds. So we have 5 observations. These are the time period. So at first they take the time from this position to this position, again back from here, then back. This time is taken to be 2.63. The next reading, okay, we got 2.56, then the next 2.42, 2.71, then 2.80. So to find the absolute error, to calculate the absolute error, what do we have to do? First we'll have to know the true value. So we'll have to calculate the true value first. And how do we calculate the true value? To calculate the true value, you'll have to sum all these measurements here, and you divide it by the number of observation, which is 5. So here the mean, which is the true value, is a summation of all these 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80. Then you divide it by the number of observations, which is 5. If you sum it, you will get 13.12. Then you divide by 5, and this will come out to be 2.624 seconds. Now you can see here we have 3 digits after the decimal point, 1, 2, 3, but in all these measurements you have only 2. Okay, or if you look at the number of digits, we have 1, 2, 3, 4 here, and here we have 1, 2, 3, 1, 2, 3, 1, 2, 3, here also 3, here also 3 digits. Okay, so these digits, they are known as significant figures. So while doing any measurement, the result should be same. Okay, the result of the significant figures should be same. So for example here, the significant figure of this result should be same as this one, this one, this one, this one, and this one. So what we do here is we'll have to round it up. Okay, rounding off. So here we look at the digit after the second decimal digit here. So this 4 is less than 5, and if it's less than 5, then we just ignore it. Okay, so your measurement, your true value, will be equal to 2.62. So now we have 3 digits here, 3 digits. So this is the correct way of writing it. Okay, so 2.62. We'll learn more about significant figures in the later stages. So we have found out the true value. What's the next step? We take the difference. Okay, to find the absolute error, you'll have to take the difference. So what you do is, you take the difference of all these with the true value. So delta A1, delta A1, delta A2, delta A3, delta A4, and delta A5. So delta A1 will be 2.63 minus 2.62. This will be minus 2.62, minus 2.62, minus 2.62, minus 2.62. So that is the difference. Okay, so upon taking all the difference, we've done this first step. We've got the true value. Now we take the difference, and here it comes out to be 0.01 seconds. Here it comes out to be seconds. So here it comes out to be minus 0.06 seconds, and here it comes out to be minus 0.20 seconds, and here it comes out to be 0.09 seconds, and here it comes out to be 0.18 seconds. Now this is the difference. Now what's the absolute error? You'll have to take the modulus of all these. So the absolute error of the individual measurements, you take the absolute error, take the modulus of all these difference. So take the modulus, take mod here also. You take all the modulus. So upon taking the modulus, of all the measurements, so modulus of this will be 0.01 second. Here modulus of minus, we'll write only 0.06 second. Then this will be modulus of this, you'll get 0.20 second, and modulus of this 0.09 second, and modulus of this 0.18 second. So we have all positive values, which are the absolute errors in the measurements. And then the next step is to take the mean absolute error, that is sum all these values. Okay, so here I'll sum it here. You add all the values, what you'll get is 0.54 second. Okay, so this is the summation of all these, 0.54. So your mean, which is delta mean absolute error, delta A mean, this will be equal to 0.54 second. So we have found out the absolute errors in measurement. Next one, we can find out the relative error. How to find the relative error? Now we have given you the formula of relative error. What you do is you divide this delta A mean by the true value, which is 2.62. So we've got the mean absolute error. Now find the relative error. Relative error. So this will be equal to the mean. This is the formula. Mean absolute error divided by the true value. So mean is this 0.54. Oh, sorry. This first, what you do here is you divide it by 5. Okay, this is the sum, and you have to divide by 5. So what you'll get is 0.11, sorry. So here the mean will be 0.11 second, and the true value is 2.62. So if you divide this 0.11 divided by 2.62, what you'll get is around 0. I'll write it here. 0.04. Okay, but after rounding up, I'll get this one, 0.04. So that is your relative error. Now if you look here, the relative error has no unit because this is second, this is also second. So you can cancel out, so the relative error will be, has no unit, Now the percentage error, how to find a percentage error? You multiply this with 100. So multiply the relative error, 0.04. So what you get is 4%. So this will be your percentage error. So this is how you will calculate absolute errors, relative error, or percentage error. First, you know the true value, then calculate the difference, then take the mean absolute error, then calculate the relative error and the percentage error. Okay, so step by step. Then calculate the relative error and the percentage error. Okay, so step by step.